Okay, Algebra. Today we're going to be looking at some properties of identity and equality. And a lot of this stuff is going to be looking pretty obvious, but it's nice to get it down on paper. And these properties are going to come in handy when we start solving equations. We're going to be looking for these. Okay, so first off, let's try to solve these open sentences. So on the left side, go ahead and find a value for x that makes 7 plus x equals 7 true. Okay, the only number that we can substitute in for x that makes this equation true is 0. 7 plus 0 is equal to 7. So adding 0 to a number does not change its value. Now let's try the same thing with multiplication. So on the right side here, we've got 4 times y equals 4. Try to find a value for y that makes this true. Okay, the only value of y that makes this a true sentence is 1. And multiplying a number by 1 also does not change its value. So these open sentences are examples of the properties of identity. So first off, we've got the identity property of addition. So 0 is known as the additive identity. This means that adding 0 to any number will not change its value. So we could say that x plus 0 is equal to x for any x we put in there. 7 plus 0 is equal to 7. 24 plus 0 is equal to 24. 100 plus 0 is equal to 100. It doesn't matter what we put in for x. If we add 0 to it, we get the same thing. And then on the right side here, we've got the identity property of multiplication. So 1 is known as the multiplicative identity. This means that multiplying any number by 1 will not change its value. So if we've got y here, we can say that y times 1 is equal to y no matter what we put in for y. So if we put in a 4, then 4 times 1 equals 4. If we put in a 7, 7 times 1 equals 7. So this is the multiplicative identity. And you've probably picked this up over doing math for the last however many years, that 0 and 1 are pretty important numbers. They're kind of the cornerstones of the numbers that we use. So you kind of knew this in the back of your head already, but we're throwing out actual properties with them now. Okay, we do have a couple other multiplicative properties that happen only with multiplication here. The first one is known as the zero product property, and that says that multiplying any number by 0 will result in a product of 0. So remember, a product is the answer when we multiply two numbers together. So that means that in an algebraic expression here, I guess this is an equation, x times 0 is equal to 0, and it doesn't matter what value of x we put in. So we can put in any number we want, and then that number times 0 is equal to 0. And then over on the right, we've got the multiplicative inverse. So that says that the multiplicative inverse is the reciprocal of a number. So we're dealing with fractions here. If you take a number and then you take, like, say you have a fraction 1 over 2, and you flip it upside down, that would be the reciprocal, 2 over 1. We could do the same thing with a whole number, like if we've got the number 8, then its reciprocal would be 1 over 8, because we know that 8 is the same as 8 over 1. So we're just taking that fraction and we're making the numerator into the denominator and the denominator into the numerator. That would be the reciprocal. But that's important because a number times its multiplicative inverse will always result in a product of 1. So 2 times 1/2 is equal to 1. 8 times 1/8 is equal to 1. And we could say that y times 1 over y is equal to 1 for any value of y except for 0, because we can't have 0 as the denominator of a fraction, so that 1 over 0 makes bad things happen. We can't divide by 0, but any number except for 0, if we take that number times 1 over that number, it will be equal to 1. All right, let's try a few of these. So number 1, we've got 24 times n is equal to 24. Go ahead and solve for n and then name what property you used. Okay, n is equal to 1, and that is because 1 is the multiplicative identity. Okay, number 2, let's try this. We've got n plus 0 is equal to 15. Okay, if n plus 0 is equal to 15, then n has to be 15, and that is because 0 is the additive identity. And then number 3 here, n times 9 equals 1. So think fraction here. Okay, n has to be equal to 1 over 9 or 1/9, and that is because that is the multiplicative inverse of 9. So we want two numbers that when we multiply them together we get 1, so we're looking for that reciprocal there. Okay, and then just to finish things up here, we do have a few properties of equality. These are a little bit less important than the ones we've done before, but still good stuff to know, and some of it's going to be pretty obvious. So the first one is the substitution property, which we've used. Any two values that are equal to each other can be substituted freely between one another. So for example, if we've got an equation here, x plus y equals 7, but then we find out that x is equal to 3, then we can change that equation to 3 plus y is equal to 7. So we just substituted in that 3 where x was. Another one would be the reflexive property. This is a really obvious one. It's not going to come up much in this class, but it does occasionally come up in geometry. And that says that any number is equal to itself. So that says x is equal to x. Or if we want to put an actual number there, 25 is equal to 25. It's pretty obvious. Another one that we've got is the symmetric property. So this is kind of useful if we want to, sometimes it's easier to think about that variable on the left side when we're solving equations. But the symmetric property says that the sides of an equation can be freely switched. So we can just go left equals right, right equals left. So as just a numerical example here, if x is equal to 18, then 18 is equal to x. So it goes both ways. And then finally, the last one here is the transitive property. So this is kind of useful if we've got like a multi-step equation here or a few different equations. This says that if two values are both equal to a third value, then those two values must also be equal to each other. So as an example here, if we've got x equals 6 and x equals y, then y must be equal to 6. So 6 and y are both equal to x, and if they're both equal to x, then that means that they must be equal to each other. So that's what the transitive property is saying. We've got these two different values, y and 6, but they're both equal to that third value, x. So they have to be equal to each other. Okay, that's all for this one. A little bit of a short lesson, but good stuff to know. Make sure you bring any questions, and we will work on this in class.